Trace the curve x square y square is equal to a square into y square minus x square. First point, symmetry. As powers of x and y are even, curve is symmetrical about x and y axis, both the axes. Second point, origin and tangents at the origin. Put x is equal to 0 and y is equal to 0 in the equation, and if we get 0 is equals to 0, that means curve passes through origin. And as curve passes through origin, we find the equation of the tangent or tangents at the origin by equating the lowest degree term or terms to 0. Here the lowest degree terms are a square into y square minus x square. Equating it to 0, we get y square is equal to x square, means y is equal to plus minus x. There are two different tangents at the origin, and therefore we get a node point at the origin. Third point, point of intersection with the axis. Put x is equals to 0 in the equation, we get y is equal to 0, and put y equal to 0, we get x is equal to 0. That is, origin is the only point of intersection. With the axis, x-axis as well as y-axis. Then fourth point, asymptote parallel to y-axis. Procedure is that we have to find the highest degree term in y, here the highest degree term is y square multiplied by x square minus a square. Then equating its coefficient to 0, we get x square minus a square is equal to 0. X square is equal to a square, means x is equal to plus minus a. These are the two lines as asymptote, means becomes a tangent at the infinity to the curve. Then showing all this in the figure, curve is symmetrical to x as well as y axis, passing through origin. Therefore origin is the point, and then tangents are y equal to plus x and y is equal to minus x. These are the two tangents as shown in the figure, and therefore at origin we get a node point, y equal to x, y equal to minus x, and origin is the node point. Then the asymptote, x is equal to plus a and x equal to minus a. Therefore this is x equal to minus a, and this is x is equal to plus a line. These two lines are the asymptote to the curve, and therefore we have to make a parallel part of that curve to this line, slightly parallel. Therefore making a parallel part Yes, this is the parallel part. And then joining this parallel path to the origin, as curve is symmetrical to y-axis, we have symmetrical part about y-axis, and as symmetrical to x, symmetrical to above part. Therefore, this is the required curve. Then the last point, region. Solving the equation for y, we get y square is equal to minus a square x square divided by a square minus a square, multiplying by minus inside, we get a square x square divided by a square minus x square. Then for x greater than a, we get y square as negative. That is, y is imaginary if we take a square root of this negative term. Curve does not exist. And similarly, for x less than minus a, again y square is negative. Y is imaginary. Means curve does not exist. Means what? Curve exists only between x equal to minus a to x is equal to plus a is the region where curve exists. And all this is shown in the figure. Thanks for watching.